Right. Hello, guys. So today we are going to cover a topic about Taskflow API in Airflow, which is a little bit complex topic, and we'll be covering it up today. And uh, and today is the third learning session, I think, and we are resuming after 2 days. So I took some break because the first 2 days were a little bit like longer sessions, and I wanted to rejuvenate myself and then come back in doing another topic in Airflow. So in today's learning, we are going to do we are going to start with a recap of what we learned as last session. And I think we covered up how to install Airflow in our first session. And then we saw basic things like how to install it, how to set up the environment variables, how to install Python virtual environment, how to install Python, and all those topics we covered in our first session. And then in the second session, we covered about how to set up our first pipeline on Airflow. So we covered the tutorial section uh, of the official documentation. So we did that couple of exercises, and we so far we know about what are DAGs and what are tasks in Airflow, and we are familiar with those topics. Today, it's an extension of how to implement the pipeline, the orchestration of a data pipeline using Taskflow API, which is another concept in Airflow. So it's released in Airflow 2.0, and it's much more simpler than creating a data pipeline on Airflow using the traditional method. So that's exactly what we are going to cover today. So let's first start with the recap. So let me go to the Airflow documentation page. So first session we had the Airflow quick start where we installed Python 3.10 we installed, and then we did a set up the environment variables like this, and then we did a pip install, and we were running the Airflow in the standalone mode. We also created a user to using this Airflow users create command by setting the username, first name, last name, role, and email. And then we started Airflow web server in the port 8080. We did that, and that's it. So I think we did all those operations, and also the second day we were not able to do the backfill and running a sample task, testing a sample task using these commands. But in the second day we were able to do it. So this backfill is nothing but if you want to run the backfill on the previous days. Let's say you have a pipeline, our pipeline has a set of 3 tasks, and you have to run those 3 tasks for the previous day's data. If you want to backfill the data into a database, or if you want to backfill the data into some file storage like Amazon S3 or something, we can do that. And so we were able to run this using this command. So this is nothing but Airflow, DAGs is a keyword, and backfill is also an operation name. An example bash operator is a tag title, that is the name of the tag. And the start date and date we gave like this, and then we were able to run this also. So we did this in our first couple of learning sessions, and then we went to the second session. We went to the tutorial section, and then we learned about the basic concepts, the fundamental concepts, where we saw this. We examined this tutorial.py file. So it's available in our Airflow installation directory in example underscore DAGs folder. We are able to see that. And yeah, we created this. We studied about this. What is a DAG? How to initialize a DAG? How to import a DAG and initialize a DAG using title, using default args, and description, scheduled start date, catch up tags, and all that. We were able to get an idea about what are all those things. And then we also did go through about bash operator, which is nothing but how to create a task using a bash operator, and give a task ID in bash command. And we were covering up those topics, and also Jinja templating using the shell commands to do some operation. So we did all these, we did cover all these topics, and we were, yeah, we were just going through this documentation, templating with Ginger, and that's it. I think we did this, we did cover this, and we also study about different kinds of bit shift operators, as well as different operators to set the task order in which they have to execute, and what are the dependencies between the tasks. We set this up in our last learning session. And yeah, I mean, also we did a testing of our tasks. We did that also. So backfill testing, and that's it. So we covered all these topics in our last learning session. So today, we are going to continue the next step of the tutorial with working with Taskflow. So Taskflow was introduced as part of our Airflow 2.0. That's the version that Taskflow started, and it's a alternate. It's yet another way to initialize the DAGs. It's yet another way to initialize the tasks in Airflow. In the traditional paradigm, we write tasks with a command called with DAG. We import the DAG, and with DAG, and then we give the parameters of the DAG inside the DAG constructor. We do that, and then within the DAG initialization, we write different tasks using Python operator or Bash operator. That's the traditional way of implementing a pipeline on Airflow. So let me show you how it is implemented here in example DAGs. Let's say we are going to tutorial.py. That's the file that we were using in our previous Airflow installation. So also this Airflow is throwing an error here. So it says that import Airflow could not be resolved. So let me give you a way to have the Python environment set up, the interpreter set up in Visual Studio Code. So it says that we want to install the recommend Python installation. Yes, let's install it. So we have installed it, and yeah, it still says that. So what we are going to do is we are going to go to the right bottom corner, and we are going to click this 3.10. So this is the interpreter that it is currently using. So let's have a different interpreter. So in my other Visual Studio Code, I have the path for the interpreter, which is if you press Command Shift and P in our Mac environment, or if you do this interpreter, so it says that library frameworks python.framework versions 3.10. This is the virtual environment path, the Python 3.10 path, where we have installed Airflow. So let us also include the same interpreter in the other Airflow window also, in the VS Code window. So in the other VS Code window, not Airflow, it's a VS Code IDE that we are using. So let me also include the path here. So let me go to Python framework library, Python framework version 3.10, Python 3.10. Let me open the terminal here. So open the terminal. What is the path name? 1 second. Path is okay. We have to go to versions. We go to 3.10. Python 3.10. Let's give this path. not able to get this path. Let me check that here. I'm not able to do this here. Okay, so these are all like different kinds of problems we will face. Let me click here. Let me go to interpreter path. Fine. Let me find it from my window. So let's say I'm going here. I'm going to bin. I'm going to Python 2.10. Okay. Select interpreter. Let's select that interpreter. So yeah. Okay. Yeah. It automatically gets the path here. So that's it. So now you can see that the Airflow error not able to import is gone, and it is able to import it. And let's dive in deeper into this code of tutorial.py, how the uh, traditional DAG and has been implemented, how a traditional pipeline is implemented on Airflow. So first, what we have is we are importing the DAG, and then we are using with DAG. That's the command that we are using. That's the start instantiated DAG. That's the command we are using. And then we are using tutorial, which is the DAG ID, and then we are using default args and all those commands. And within this DAG, we are giving the alias name as DAGs, lowercase DAG, and within this DAG we are implementing the tasks, just various bash operators we have implemented. So T1, T2, T3, and then we are using T1, T2, T3 here. So this is how we are the traditional way of implementing the task after setting up the task, after defining the tasks T1, T2, T3. Just using a bit shift operator to define what are the tasks to T1 first has to execute, and T2 and T3's execution depends on T1, and T2 and T3 are executed in parallel after T1 is successfully processed. So that's the task execution setup that we have. So this is the traditional way. This is the traditional paradigm that we are using on Airflow. So let me also zoom in and show you guys a little bit more clarity on how it is implemented. So we have DAG and we have tasks and we have all this commands, like, and then we are setting the dependency here. So yeah, so this is the traditional paradigm. So if you want to move away from this, and if you wanted to use Taskflow API to implement the pipeline, we are going to do that today. We are going to see how it is implemented and then learn from it. So the name of the tutorial, name of the file is tutorial underscore taskflow underscore API.py. So let me show you that. So before that, we need to know about something called decorators in Python. So we'll be using decorators in Python to implement a pipeline on Airflow. So we'll be using multiple decorators there. To have the decorator setup, to know about decorator, I've created something for you guys to study about decorator, how it is implemented and how decorators function in Python. So let's dive in deeper into decorators to begin with, and then I'll take you through how Taskflow API in Python is used to implement a pipeline. So decorators are nothing but it's a way to have a Python method execute function in a customized way. We will define a method in Python, but we won't change the method after defining it, after implementing it. Instead, we use decorators to call the function in a certain way and customized way. So that's when decorators are being used. Without changing the function, we are going to define the way how functions operate, and we are going to customize way how functions operate. So those are decorators. So to understand a little bit more about decorators, let's say we have a concept one, which is calling a function within a function using parameters from outside the function declaration. That's the concept one. So in this concept, let me zoom in a little bit. So in this concept, I have to study this concept, I have implemented a method called outer, which is taking a parameter called x. And inside outer, we have another method called inner, which is taking a parameter y. And what inner does is it is going to return x plus y. It is going to add x and y attributes and it is going to return it. And this outer method is returning an inner function. It is returning an inner function, which means it also returns the addition of x plus y. That is the sum of x plus y. That's the overall function of outer. That's the overall responsibility of outer. So here what we are doing is we are creating a variable called add5. So we are defining something called outer5, and then we are defining a let's print add5 also. We are also defining something called result, which is adding which is having an attribute called 6 is appended to this add5. So how does this work? How does this function? Um, so So let's debug and see how this functions. So run debug. We are debugging. So I've created a breakpoint here. So this is how you debug in Visual Studio Code. So I've created a breakpoint and I'm gonna step into this add5. So add5 is a variable that is created and then it is implemented by calling this outer function and passing this parameter called 5. So we have something called, let's see the call stack here. We have something called, we have the local variable x is set as 5. We have inner variable y. So let's return inner. So let's print. What does a print do? So print is defining a function called outer.inner. It's defining a function. So if I again add 6, if I again include a parameter called 6, it is going to the inner function. So it is going to the inner function and then it is setting the attribute called 6 in y, and then it is returning 6 in the result. If you see here, 6 plus 5 is 11. That's the result it is returning. So it's doing a addition, and this is the concept one. So that's the this is the overall function this does. And add5 is not, once we declare add5 is nothing but inner. That's the function, and then we are using the inner function and having an attribute called 6. Then add5 is nothing but inner. So once we define add5, add5 is nothing but outer of 5. So it goes to the outer function. It is with a parameter called 5, and then it doesn't execute the method. It returns inner, which is nothing but it is returning the function called inner, which is assigned to add5. Now add5 is nothing but inner function, and then it is when we are printing add5, that's why it is declaring as function outer.locals.inner at something. So add5 is nothing but in this line, when the line 10 is executed, when it is printed, we are printing the function called inner. And then for within that inner function, we are calling that inner function and storing the value and result. So we are inner function has an attribute called y, and that's what we are passing here as 6. So what it does is it is returning x plus y. So x is already defined as 5 before, it stores it, and then when we are calling the inner function with parameter 6, it is going to add 6 plus 5 and then print it in the line number 12, so which is 11. So that's the overall concept here in this code, in this concept 1. So let's say concept 2. Let's go to concept 2, which says that calling a function with another function or as a parameter along with other parameters. So in Python, in function parameters, we can pass a function. Like in the parameter, we can pass another function. We can do that in Python. I'm not sure about other programming languages, but in Python we can do that. So here in this concept 2, I've defined a function called add, which takes two parameters called x and y, and then it returns x plus y. And then we are doing something called calculate, which takes in a function parameter as function, just func, and it is also taking x and y. So what calculate does is it is going to call the function which is passed as parameter along with x and y. So this function, when we are calling, it should be defined outside this calculate function, which takes in two parameters called x and y, and that is what this add is. So when we are calling this calculate along with add function and 4,6, it is going to add 6 plus 4, which is 10, and it's going to display the result. So let's see here. So let's see, even when I just quickly did that. So when I'm going to calculate, and then it is going to calculate, which is nothing but returns function. It is going to function called, we are passing add as a function, right? So it is going to add when this line 21 is executed, it is going to add, because function here is add, and it is going to add, and x and y it is passing, which is 4 and 6, it is passing here in add, and then add is returning x plus y, 6 plus 4, which is 10, and that's it. It returns back, and then it returns 10 as the result, and it stores in result variable, and print result will display 10 here in the terminal. You count down and see in the terminal. Let me use something. So you see here it's 10 here. So 11 is the previous result, which is concept 1's result, and 10 is the next concept 2's result. So let's go to concept 3, where we are returning a function as a function return type. So the return type can be a function. Here, the return type of outer is also a function. Similarly, in concept 3 also, we are explaining the same. We can define a function, and the return is also a function in any function. The method can return a function or a method. A method can be called as a function, or function can be called as a method. So don't get confused. So in certain programming languages, function is called as a method, and in certain languages it's called as function. So I might confuse when I might use two different terminologies. So don't get confused. So here greeting is a function I have defined, and hello is a function inside greeting function. So we can have the return type of greeting as hello. So it's which is another function. We can do that. So this hello doesn't have any, it's just returns a string, and it doesn't take in any parameters. But greeting takes in a parameter, but hello uses that parameter which is defined in greeting. That's it. So that's the overall concept here. So overall logic I wanted to explain is a function can return a function. So a return type of a function is a function. So that's what I wanted to explain. So I think I'm confusing a lot, but yeah. So this is a concept. So yeah, so if you see here, it is going to print hello Atlantis and exclamation. That's it. So we have come out of the debugger because all the lines are executed. And if you see here in the result, we have printed hello Atlantis. So yeah, so these are three concepts in Decorator. And we are always calling a function and then storing the value of the function in a variable. So that's what we have done so far. But decorators, when it comes into picture, so that's what we are going to dive in now. It's just going to take like another 5 to 10 minutes to explain the concepts, and then I'll show you how you should define a decorator in Python and how we can use it, when we can use it. So concept 4 is calling a function normally and calling a function with another function as a parameter. So let's say we have defined a function called make pretty. And inside make pretty, we are defining a function called inner. So inner, what it does is make pretty has an argument called function, which is func, and that is being called an inner. And inner is also printing called I got decorated. And ordinary is another function, which is printing I am ordinary. So if I run this debugger in this, and then I'm setting the breakpoint here. If I'm calling ordinary, it is going to print I am ordinary. That's it. If you see here, it is printing I am ordinary here. So that's all it does. If I'm calling make pretty with ordinary, it is going to first go into make pretty with ordinary as the function, and then it goes to this line 5. It is not going to execute because it's a function, and then it directly skips line 5 to 7, and then it goes to return inner, where it will call the inner again. It control will pass to the line 5. It gets inside inner, and then it first prints I got decorated, and then it prints I am ordinary because there is a function call here which is nothing but ordinary, which we are passing it in the argument as a parameter. So that's what it is going to do. So the output of the result I'm expecting is it should first print I got decorated, and then it should print I am ordinary. So the first line number 13 already printed I am ordinary. So the next two prints should be I got decorated first and then followed by I am ordinary. So that's what I'm expecting. It's not doing that. So what this ordinary will do is it will print the print statement from ordinary, and then what make pretty of ordinary will do is it is just going to call make pretty, and then it is going to return inner. So that's what this entire function does. It is not going to print I got decorated. It is not going to print I am ordinary. I'm hoping so. So let's see. Let's run and debug this. It goes into, it prints I am ordinary here in the terminal, if you see here on the bottom, and then it is calling make pretty, and then it is defining I am ordinary again. So because make pretty is calling I am ordinary here, and then it is defining make pretty. That's it. So it doesn't. Let's go to concept 5. So concept 5 is calling a function using a decorator function. So we can call a function using a decorator. Like we can, let's say if you want to decorate this ordinary function using make pretty, you can call a function by passing this ordinary as a parameter, and then you can store the variable of the make pretty. Like define make pretty is nothing but the return type is a function. Once you have defined the make pretty, once you have defined the return type, you are going to call that make pretty function again. So we are going to do that. So decorator function, if you call again, it is going to first print I got decorated, which is first, and then it is going to call the function called ordinary. It's going to print I am ordinary, and that's it. So that's what this decorator does. Like it's a calling a function using a decorator function. So is it the only way to implement this in Python, or do we have any other way? So we have another way called using decorators. How do we use decorators is something which we are going to cover now. So decorators is nothing but we are using an @ symbol to define a decorator function. So for example, if you want to do the same operation of make pretty and then call ordinary within the make pretty, if you want to do the same functionality, we can use an @ operator above ordinary, and then use a name called make pretty for the name same as the name of the function after @ operator. So we can use that @ symbol, and then we can do that. That's what I have done here in the line number 50. So once you call ordinary again after defining a method, after defining a function with the decorator, it is going to execute the same way. So it's going to print I am decorated, I got decorated, and then it's going to print I am ordinary, and that's it. So this decorator also takes in some function parameters. Like I said before, you have the same concept learned in concept 1, which is nothing but calling a function with parameters. And then we are going to do the same with @ operator now in concept 7. So we have something called smart divide, which takes in, which has an inner function called a comma b. Those are two parameters. So once you define divide is a function which we are planning to decorate with smart divide. So if you wanted to divide, if you wanted to decorate this divide function with smart divide, we have to first call this smart divide. So smart divide, it returns an inner function, and then once we have the inner function defined, we have to call the inner function with these two parameters again. So that's a two call. And so making two calls, I'm going to use decorator to do that again. So if you use divide 2 comma 5, it is going to go inside, I'm going to divide a comma b, and then it is returning a function, and It's going to divide 2,5 and then it's printing 0.4. That's the result it's doing here. So that's the concept here in divide. And then we divide 2,0 will not print divide anything. So it's going to return. So that's what it does. We can also use chaining decorators. Like we can also use multiple decorators for a function. And see, let's say if you have star and person, which is going to print 15 occurrences of star, then call the function, then again print 15 occurrences of star. And then you have person which prints 15 occurrences of person, and we are going to call a function and then print 15 occurrences of person again. So if you want to chain these two operations for a printer function and use the decorator called star and person, that is the name of the function decorators, we are going to chain them too. Like we can use multiple decorators here. So what it does is it's going to first print 15 occurrences of star, and it's going to print 15 occurrences of person. It's going to call this function, then print 15 occurrences of person again, then it prints 15 occurrences of star. It is going to sandwich the hello call. That is, hello is the name of the argument for the printer function. It's going to sandwich hello with star, percentage, hello, percentage, star. And all the number of stars are 15, number of percentages are 15. So that's what it's going to do. Let's see here. The printer is going to define it. And then when you printer of hello, it's going to print 15 occurrences of star. It's going to print 15 occurrences of percent. It's going to print the message. It's going to print 15 occurrences of percent, and it's going to print 15 occurrences of star. That's what it does. So if you want to execute person first and then star next, you can do that by interchanging the chaining in the decorator here. So we can also do that. So that's the whole concept here. So that's what it is doing here in the debugger. So yeah, that's it. So that's the overall concept of decorators. So why did I explain in detail about decorators now? It's because we are going to use that in Airflow, in the Taskflow API in Airflow. So we're going to use decorators, we're going to use DAG decorators, we're going to use task decorators, we're going to do all those, we are going to use decorators in our code, and then we are going to review it. So let's dive deeper into the Taskflow API. So Taskflow API has, let's review the Taskflow API.py file. So like I said before, you see here, you have DAG decorator, which is imported from Airflow decorators library, and it's importing DAG and task. So once you define a DAG decorator with an @ symbol, and then whatever parameters we want to use for DAG, we are going to use it. And then we are going to define this @DAG for a method, which is nothing but tutorial Taskflow API. We're going to do that. It's nothing but we are defining a DAG called tutorial Taskflow API with these parameters, with these settings. And then we are going to call this DAG below in the same code. We're going to call this tutorial Taskflow API below. So that's what we did here. So that's how we define a DAG in the new Taskflow API from Airflow 2.0. So next we are inside this DAG definition, inside this DAG method definition, we have something called extract, which is a task. We are using a task decorator for extract, which is nothing but a task. We're going to use transform task, which is again a task. We are using a task decorator for transform also, which takes in a parameter. And then we are defining a load, which is again a task, and we are it also takes in a parameter. So those are the three tasks we are going to define in this implementation of Taskflow API. So let's review extract, what it does. Extract has a JSON string which has different key value pairs, and then we are converting into a dictionary by using json.loads. We are importing a JSON here. Whenever you want to convert JSON, we have to import JSON library here from Python. It's an inbuilt library. So we are using json.loads, which converts this JSON string into a dictionary key value pair, and then we are storing it in order data dict, and then we are returning the order data dict. That's all it does. It is having a hard-coded JSON string. It is converting that into a dictionary, and then we are returning it. That's it. That's what extract does. Okay, let's move on to transform. What transform does is it is taking the order data dict. It is taking the order data dict from extract, I think. That's what is being passed here. And we are not passing it in while defining the method. We'll see how we are going to pass while constructing the pipeline. So it's also a task which takes multiple outputs, which is true. And then we are what transform operation does is it is going to define order value is equal to 0. Okay, and then it is going to iterate through all the values in the data dictionary. That is nothing but order data deck. We have 301.27433.21. These are keys and these are values. We are going to sum up all the values, I think, and then we are going to return another dictionary, which is nothing but total order value is the key, and the value is the sum of all the values in the previous order data deck. So that's what transform does. Load is another task we are defining, which is taking the value called or total order value. It is taking the output of transform, and then it is printing the output in 2 decimal places. That's what load does. So how do we pass on these arguments? Like how do we pass on the output from extract to transform, transform to load, and how do we call extract, transform, load? We have just defined the task, but how do we call them in the pipeline? That's what it's written here in order data as extract. And if you see here, order data is passed as a parameter to transform, and we are storing the value output of transform in order summary. And then order summary is nothing but key value dictionary, which is total order value, and value is total order value. We need this total order value from order summary, so we are passing that value only to order summary, which is going to print that. So that's what this does. This entire pipeline does. So that's the explanation that's given. Whatever I explained to you guys, it's what is given in the documentation. So how does it differs from the traditional paradigm of defining a DAG and a task? If you wanted to do the same operation in the traditional paradigm, how do we do that? So to do that, let's review the traditional paradigm documentation. So this is the Taskflow API like we saw now. This is the Python file that we have. So let's see whether do we have tutorial tag. So this is another Python file that implements the same extract, transform, and load. It's also given in this documentation. You see here, right? We are not using decorator. We're using a traditional paradigm of importing the DAG and then using a with command to initialize the DAG. So that's what we are doing it here. So what does extract do? Extract takes in a TI, which is nothing but task ID, I think. It is defining a JSON data string, and then it is pushing the order data, this JSON data string, into this order data. That's what it does in extract, which is using something called XCOM push. So XCOM is a important operator that we need to know when we are using a traditional way of defining a DAG. So XCOMs are nothing but it's a mechanism. It's called it's a short form for cross communication. So if you wanted to see in the Taskflow API that is from Airflow 2.0, we are passing the output of task 1 to task 2 in this way. We are doing that by directly doing that when calling a function. That's what we are doing in Taskflow API. How do we do that in traditional paradigm is by using XCOM. That's the mechanism that we are using. So what XCOM does is in extract, it is just pushing the output of extract, that's just data string. And then it is having a TI. What is TI in XCOM? Let's see what is TI in XCOM Airflow. Task instance is TI. So I think we are defining TI task instance and then we are pushing the data. In transform, if you want to use the data from extract, if you want to use the output from extract in transform, we are going to do that by using XCOM pull. And the task ID is nothing but extract, key is order data. So that's what we are doing. And then we are doing a JSON.loads of transform, and then we are summing up the values here. And then we are storing that sum of all the values in total order value here. And then we are doing a JSON.terms of total order value. And then the output of transform is again pushed using XCOM underscore push. And then it is storing a key value pair. What does load does? Load again pulls from using XCOM underscore pull, and the task ID is nothing but transform. The key is nothing but total order value, and then it is going to print it. And then we are calling this separate extract transform load using Python operator, which is nothing but Python callable. So this is the overall operation that we are doing in traditional Airflow implementation. And then we are doing extract transform load. We are using a bit shift operator to define the order of execution. Here we are defining the order of execution in this way, just one after the other, calling the methods. That's it. So that's how we are doing it here in Airflow API 2.0. So those are the law concepts and difference between Airflow API 2.0 and that is Taskflow API and a traditional way of implementing a task. So they are also explained about reusing a decorated task. Okay, so this is an interesting concept. So if you wanted to reuse a decorated task, for example, we are using a task called add task, which is nothing but is just taking in two parameters called x and y. And then we are defining task x is equal to x and y is equal to y. These are task arguments, x plus y. So if you want to use this add task in our DAG, let's say we are creating a DAG called my DAG, and it is using add task dot override of task ID is equal to start. So we are defining a task ID called start, and then we are calling this add task with two parameters called 1, 2, and then we are doing a start. We are using a bit shift operator for a task ID 1, which is nothing but task, and then we are using a add task called add start of 1, something like this. So if we are calling two DAGs here, so that's what it does. Let's see how what are the parameters of DAG, my DAG. Let's see whether do we have my DAG here. My DAG is not here, so let's see. We don't have it here. Okay, that's not there in any Python file. We are not defining it. So we will see. We will experiment all this. So, and then we are doing a complex and conflicting Python dependencies. We will see this how a task can be reusing a decorator task. We will see how in the next session. So for now, we have understood about the differences between traditional paradigm of defining a DAG and then using a Taskflow API in Airflow 2.0, how we are defining it, how we are ordering the tasks. We understood that. So let's quickly experiment with one thing. One question I had in my Taskflow API while learning Taskflow API is, see, we are naming the task as the name of the method. Can we name the DAG? We are naming the DAG as the name of the method. This is created here. If you see here, tutorial Taskflow API is here. That's the name it is given. If you wanted to name the DAG as a different name, if you want to give a different name, can we do it? Is my question. So let's see. Let's copy this code. Let's go to um, our DAGs folder, and then let's create a new file called tutorial Taskflow API money.py. So we are doing this, and let's say we have something called DAG ID. We have a DAG ID. Let's say tutorial Taskflow API underscore money. Let's do that, and then let's see. You see here we have tutorial Taskflow API money. It's created. So you see the DAG ID that I gave for this DAG is tutorial Taskflow API underscore money, but the DAG method that we are defined is nothing but it doesn't have a prefix called underscore money. So we have that different DAG ID created. So I think we can give a different name to the DAG. So that works. So yeah, I mean, this is a cool stuff. So we are defining a DAG and the DAG is defined again. So yeah, we have these things defined. So yeah, that's the I think we have learned this concept of Taskflow API, and we are completely in control of what are the different things that we have currently in the Taskflow API. So I think tomorrow or maybe this week we will learn about how to reuse the existing task. Reusing a decorated task we will learn in the from the official documentation. And then we will also cover complex dependencies, Python dependencies. We'll cover that in the upcoming session. So yeah, okay. So let's see in the next session, and hopefully it'll be a little bit more complex, and we will learn different complex topics with these. So that's it for today. Have a nice day, guys. Cheers. Bye.